Hello everyone. Welcome to the second edition of Java Week. My name is Sadanand Aital and I'm part of the Java Level 3 service team here in Java Technology Center. Today I'm going to talk briefly on the parent delegation model of class loading in the Java virtual machine. The agenda for today is I'm going to talk briefly about class loading and the class loader, the role of the class loader in the VM, status of class loading, and finally the parent delegation model. So class loading and the class loader. Take a simple hello world program. Here, the first program for any programming language. Take a simple hello world Java program. Before you run this program, we compile it into what is called as the Java class file using the Java compiler. So the compilation process gives us the hello world.class file. Now this class file is actually a binary file, and the format of this binary file is defined by the JVM specification. Before the JVM actually executes this class file, it loads the class file into its memory. This process itself is called as the class loading. So, and the guy who's responsible to load class files into the JVM is called the class loader. This is in simple terms. What Wikipedia terms it as is this. Class loader is part of the Java runtime environment that dynamically loads Java classes into the Java virtual machine. So the JVM will always have access to a class through its class loader. Going on to the next slide. What is the role of a class loader? As I said, from the outset, it looks class loading is only about loading classes into the JVM, but it is more than that. Class loader, in the process of class loading, also performs what we call as linking, initializing, creating the necessary data structures inside the JVM when it actually loads a class, and bootstrapping necessary classes for your application to run as a whole. What your class loader also does is it helps the garbage collector in the process of class unloading. Now, when your class loader object is out of scope, your garbage collector will then clear the class loader and all the classes that has been loaded through this class loader. So that is why I said your JVM will always have access to a class through its class loader. Now, what this means is the class loader also allows you to create what is called as a namespace. That means you have the opportunity to load the same class into different namespaces. Thereby, you have multiple copies of the same class. Your class loader also provides a mean of security on which I will talk a bit later on. Going on to the next slide. This is a graphic which shows the sub-stages of the entire class loading process and actually depicts what is happening internally during each class load. So the stages go as follows: loading, verification, preparation, resolution, and initialization. In loading, you obtain a byte array that represents a class. Basically, you would use file open and file read APIs inside of the JVM to actually perform this task. And verification. So verification is another stage where your class byte verifier verifies the byte array that has been loaded, and it carries out certain checks so that it ensures that your class is performing legal operations. Even this has been stipulated by the JVM spec. The next stage is what is called as preparation. In this stage, the class loader will create the necessary Java and the native allocations necessary for the JVM to understand your class. So the JVM has its own structures into which the class loader will store necessary information about your class and the methods for the JVM to access. The next step is resolving or resolution. So here we do conversion of symbolic references to other classes into a direct reference. And the last part of the class loading as a whole is the initialization, where you actually run what is called as the static initializer method, and this will ensure that any static fields inside your class has been initialized to its default or the user given values. Going to the next slide. So, parent delegation model. Now, let me say what is a delegation model. It is actually a process where different class loaders delegate, or what you say, transfer the class load request to one another. In the JVM, the class loaders are created with a single parent delegation model, and which allows for the classes to be looked up in the following order. First is the cache, second is the parent, and third it will look for the class in itself. Now, a class loader will first look for a class in its cache to see if the requested class was previously loaded by itself. Now, in this case, there is no delegation required. This serves pretty well as a performance enhancement, wherein you need not do the delegation in case of a previously loaded class. Next up, the next step would be to ask its parent to load the class, and the last step would be to try and see if itself the present class loader can load the class or not. Failing all three steps, you get what is called as the dreaded class not found exception, CNFE. Now, in the second step of the lookup, the process of delegating the class load request to one's parent is actually called the parent delegation model. Now, each class loader is chained to one parent class loader. That is what I meant earlier by saying single parent delegation. So each class loader will be chained to one parent class loader, and whenever there is a class load request that comes to this class loader, it will first ask its parent to load the class. Now, this parent delegation model will end at the topmost class loader, which is the bootstrap class loader. I'll just show a small graphic which depicts this parent delegation model. Now, this is how this parent delegation model is actually represented. You have the bootstrap class loader on the top, the extension below that, and the system class loader below that. And below the dotted line is actually the user-defined class loaders, wherein the user, if he has his own class loader definition, he will chain that to the JVM. The JVM will chain that to the system class loader. Moving on to the next slide. A small brief on what each class loader is. So the bootstrap class loader is also called as the primordial class loader. This is the topmost in the parent delegation chain, and this is the most trusted of the other class loader, of all the other class loaders. So a bootstrap class loader will load classes from what is called as the boot class path. So this is basically the Java home /jre/lib/ the jars that come under this folder. How do you control your boot class path is by the X boot class path option on the IBM JNIV. The next class loader is the extension class loader, which takes care of loading classes under the JRE lib ext folder. Now, there is a system property called -d java ext dirs, which actually is used to control what all jars extension class loader is supposed to load. The next up is the application or the system class loader. This is the most common class loader which one encounters. A simple Java program is actually loaded. When you try to execute, say, a hello world, it is actually loaded by your application or a system class loader, provided it is on the class path, that is the -class path, or the -cp, or it is in the $class path or percentile class path environment variable. So these are the options how you control the class path of the application or the system class loader. And below that, if you could see, if you saw the previous slide, below the dotted line, you have the user-defined class loaders. In case of user-defined class loaders, you as the user have to specify the class path from which this class loader can load the classes. It could be a custom class path, like I have mentioned. It could be a path on the disk which is not referenced by the $class path, or it could be a network address. Now, why do you need parent delegation model? I put one bullet there. That is, the most important thing is security through delegation. Now, parent delegation model ensures that only trusted classes are loaded by trusted class loaders. So a standard example which one usually gives me is this. Say you have your own Java lang string and you try to load it through your custom class loader. Because the JVM enforces the parent delegation model, this class load will be delegated to the parent, which would eventually come down to the bootstrap class loader. And the bootstrap class loader will first check its cache and see that Java lang string is already loaded and return that reference. So thereby you have eliminated the class load of a probable suspect Java lang or your own version of the Java lang string. The JVM has actually enforced parent delegation model and ensured that only sane or benevolent code is loaded. The other point here is creation of namespaces. So every class loader will have its own namespace, and the JVM will refer a class through its class loader. So when the JVM creates namespaces, it provides what is called as protection domains to each namespace, wherein it defines what operations that the class inside that namespace can perform. So a class loader will ensure that good classes are given the right kind of permissions, and classes loaded by the user-defined or the class loaders below the dotted lines are given sufficient and reasonable permissions. That's it. That's about parent delegation model. Thanks for watching this Java Technology Byte presentation on the parent delegation model in the JVM. For more on such useful topics, please keep an eye on our Java Technology blog on Developer Works. Have a nice day. Hello, Appa. Hello.
Now departing.
Acha.